Hello everyone. In today's session, we are going to learn one of the interesting topic as process management. Under process management, we are going to cover the contents as concept of process, process management, process state diagram and process list structure. To begin with the concept of process, process is the execution of a program that performs the actions specified in that program. It can be defined as an execution unit where program runs. The operating system helps you to create, schedule and terminates the processes which is used by central processing unit. A process comprised of program code which consists of set of instructions which are written in a systematic manner to fulfill a specific task. The instructions which are going to be executed one after the other, its address is going to be held into program counter, which is a special register associated with microprocessor. A process also includes data section. Data section holds the data elements associated with the program itself. Apart from data section, it also has a stack, which is reserved portion of a memory to hold the temporary contents of variable. A process also comprises of number of attributes describing the state or the behavior of a process. When a process is mapped onto memory, it has an address space. This address space describes the code, data and stack. The address space is a portion of a memory which is accessible to end users, programmers to hold the instructions, data and stack elements associated with program. To proceed with the process architecture, there are multiple parts of a process. Informally, as mentioned earlier, a process is a program in execution. A process is more than the program code, which is sometimes known as the text section. It also includes the current activity as represented by the value of program counter and the contents of the processor's registers. A process generally also includes a process stack which contains temporary data such as function parameters, return addresses and local variables, and the data section which contains the global variables. A process may also include a heap, which is a memory that is dynamically allocated during process runtime. The structure of the process in memory is shown into a diagram, which consists of text, data, heap storage and stack. We emphasize that a program by itself is not a process. A program is a passive entity such as a file containing a list of instructions stored on disk, often called as an executable file, whereas process is an active entity with a program counter specifying the next instruction to execute and set of associated resources. A program becomes a process when an executable file is loaded into memory. Two common techniques for loading executable files are double clicking an icon representing the executable file with the help of graphical user interface and entering the name of executable file on command line, as in program.exe, or you can make use of a.out in Linux operating system. Although two processes may be associated with the same program, they are nevertheless considered to separate execution sequences. For instance, several users may be running different copies of the mail program, or the same user may invoke many copies of web browser program. Each of these is a separate process, and although the text sections are equivalent, the data, heap and stack sections may vary. It is also common to have process that spans memory processes as it runs. To proceed with what is process management, the processes are represented and controlled by operating system called as process management. The process states which characterize the behavior of processes is also been referred as process management. The data structures that are used to manage processes, the ways in which the operating system uses these data structures to control process execution is referred as process management. As a process executes, it changes states. When program executes as a process, it goes through multiple states before it completes the execution. The state of a process is defined in part by the current activity of that process. Each process goes through 5 states that characterize the behavior of the process. These states are new state, you can call it as a start state also, ready state, running state, waiting state, and last one is terminate state. The diagram shows the 5 state process related to process management. Now to begin with the new state, the process is being created by a programmer, or it may be a system process. Then that process is into new state. The program starts execution as a process, then that process is into new state. Ready state, you can say the process is into ready state. That means the process is waiting to be assigned to a processor. All the resources except the processor gets assigned to the specific process. Then that process is supposed to be into ready state. Running state, that means the instructions are being executed related to process, and when the process is waiting for some event to occur, then that process is into waiting state. When the executing process needs an input output device, or the process requests for the services, then it gets into wait state. And when the input output requirement is fulfilled, then that process goes back into ready state. The last state related to process is terminate state. The process has finished execution, then that process goes into terminate state. Or when the process completes the execution, then that process enters into terminate state. To get back with 5 state process diagram, when the new process is created with the help of system call, then that state is into new state. Then that process which is into new state, which is getting admitted, or you can say that that process is into main memory, then that process goes into ready state. Now from ready state, process moves to running state when scheduler assigns that process the processor time. Then that process moves from ready state to running state. If one of the interrupt that can be occurred while process is running, then that process moves from running state to ready state. Or when running process requests for an IO or one of her event that occurs If that process waits for the event, then that process switches from running state to waiting state. And after fulfillment of IO request or completion of IO event, then that waiting process again goes to ready state, and again the processor scheduler or dispatch manager associated with operating system moves the process from ready state to running state. If process successfully completes the execution, then that process which is into running state moves to terminate state and the completion of process execution is carried out. Likewise, each and every process may get carried through all these 5 states or minimum 2 states. Let's proceed with 4 state process diagram for the better understanding purpose. The initial process, newborn process, that is into ready state, that means you can call it as a start state. When that process moves from secondary storage and get into main memory with the help of initialization operation, then that process moves into ready state. All the processes which are there into ready state, they are into main memory and waiting for processor time for the execution. As soon as the processor scheduler assigns the processor time to the process which is there into ready state, that process moves from ready state to running state. In running state, the instructions associated with the process gets executed, and if the preemption occurs or the running process requests for the IO device or the services associated with operating system, then that running process goes into suspension states, or you can call it as a waiting state. That means the processes who are waiting for an IO, that processes moves from running state to waiting state or suspension state. After allocation of all required IO devices or after fulfilling of IO request related to the process moves from suspension state to again ready state. And after carrying the scheduling, and once the processor time gets allocated to the process, then that process which is there into ready state again moves to run state. Likewise, the process management task is supposed to be executed in a systematic manner. Now let's see the dynamic state of a process with the help of animation.